Students, in the last session we had learned about what is conduction, how conduction happens. We had also learned about convection currents, and then we had dealt about radiation. Okay, today we are going to learn radiation and the effect of radiation in detail, and we are also going to learn applications of radiation. So let us start. So, as I said, today we are going to continue with the lesson flow of heat, and we'll be dealing with absorption of radiant heat and its applications. This is part number 3 of the lesson. Student, I hope you remember what we studied in the last session. We had studied about conduction, convection, and radiation. Okay, so what is conduction? Conduction is mode of transfer of heat in which heat travels from molecule to molecule. Then what is convection? Convection is a process of transfer of heat in which heat molecules of liquid or gas themselves move to carry heat from hot to cold region. So in this convection type of transfer of heat, molecules transfer from one place to another. Okay, and last but not the least was heat radiation. It is a transfer of internal energy in the form of electromagnetic waves or radiations. So this heat transfer is because of these electromagnetic waves. So these were the three things that we had learnt in the last session. So from the sun the heat comes to us by another process known as radiation. Transfer of heat by radiation does not require any medium. It can take place whether medium is present or not present. When we sit in front of room heater, we get heat by this process. So these were the few things that we had learnt about radiation. Now comes the new topic, which is absorption of radiant heat. Radiant heat travels similar to the way light travels. In fact, it also travels with the same speed as that of the light. When light falls on an object, it is partially absorbed and partially reflected. A part of it may also be transmitted through the object. So these are the three things that happen. In the same way, when radiant heat reaches an object, it is partially absorbed, partially reflected, and part of the heat may also be transmitted. So these are the three things that happen with heat or radiant heat, you can see. Well, the temperature of the object increases due to the absorbed part of the radiant heat. Now the thing is, different colors absorb different amount of heat. For example, black color, it absorbs more heat. It is observed that comparatively black objects absorb or radiates more heat than the white objects. In general, dark colored objects absorb more and radiate more heat than the light colored objects. Now we are going to see applications of radiations. When we wear white or light colored colors in summer, why we should wear white or light colored colors in summer? Because they absorb less radiant heat. Okay, and it keeps our body cooler. So we should wear a white colored or a light colored colors in summer. Whereas in winter we should wear dark colored color like this boy. Okay, we should wear dark colored clothes in winter. Why? Because it absorbs more heat and keeps us warm during winter season. Let us see next application. Electric room heater are provided with a polished metal surface behind the heating element. Okay, so this polished metal surface helps to increase the amount of heat. This surface reflects almost all the radiant heat from the heating element that falls on it, and this makes the room heating more effective. So that's why it is reflective. Then the next application is the outer base of cooking utensil is painted black like this one. Why? Because it absorbs more heat, so the cooking can be done in less time. Let us see next application. The back of the refrigerator, like this one, you might have observed this. These are actually old refrigerators, but we had this dull black colored back of the refrigerator. And why it was done? because it radiates heat more effectively in order to cool down the refrigerator pipes. So, to make or to cool down the refrigerator pipes, we used to have a dull black colored back of the refrigerator which helped to cool down the refrigerator pipes. Let us see next application, electric hot plates. Electric hot plates like this one you have already seen, you might have seen it. These electric hot plates are colored dull black like this one. Okay, and why it is colored dull black? Because it radiates maximum heat. Well, let us see the last application for today, which is thermos flask. Students, thermos flask or a vacuum flask is used to keep hot liquid hot and cold liquid cold. This is a cross section of the thermos flask. What does it do? It prevents the loss of heat or gain of heat by any of this process, conduction, convection, radiation. It stops all this transfer of heats. Okay, I repeat, thermos flask, its structure is such that it prevents the loss or gain of heat due to conduction, convection as well as radiation. So there is no way through which heat can pass or heat can be gained. This was invented by Sir James Dever in 1892. So the invention of thermos flask belongs to 19th century. It was invented in 1892 by Sir James Dever. Well, let us see how it works. The thermos flask consists of a double-walled glass. So here there is a double-walled glass vessel resting on a cork. Over here there is a cork inside a metal or a plastic case. This structure helps to prevent the loss of heat or gain of heat. The outer surface of its inner wall and the inner surface of the outer wall are silvered. They are colored with silver. This prevents the heat transfer due to radiation. So this silver color prevents the transfer of heat due to radiation. The space between the two walls is almost a vacuum. Okay, so this prevents the heat transfer through convection. Because there is vacuum, there is no medium, so heat cannot pass through convection current, and walls are sealed at the top. The double-walled glass vessel and vacuum prevents the heat loss by conduction. Insulating stopper or cork at the top minimizes the heat loss by convection. And vacuum flasks are used, as we know, at home and laboratories, industries, to store the liquids that become gases at low temperature. So this is how the prevention of heat loss and gain helps us to retain the hotness or coldness of the substance in a thermos flask. Well, that was all for today. Now comes the assignment part. Let us see the questions that you can answer at home. The first question is, which color absorbs most radiation? Then, what are the applications of heat radiations? Here you have to mention at least two applications. Then why should we use white or light colored clothes in summer? And the last question is, how does thermos flask work? So these are the four questions that you have to answer. You will find it easy because the topics related to these questions have already been discussed. But still, if you have any doubt, you can feel free to ask me at any point of time. So see you in next session. Until then, take care. Bye bye.